Okay, today we're going to continue our lesson on quadratics, and we're going to look at the three different formats that the quadratic can be in, and we're going to first focus on what do negatives do to the formula in comparison to the graph. So here we have standard form. Ax squared plus bx plus c is the format you're most familiar with in terms of quadratic equations. And the a is always with the x squared, and the b is always with x, and the c is always the constant because it has to be in order. And so they put the letters on there alphabetically because x squared, no matter where it is in the formula, is always a. So in each of these problems, I want you to graph the original equation, 2x squared plus 3x plus 5, and y 1 or 2. I really think it'd be better if that was y2 because we're not changing that equation. I would put in y1 the three problems one at a time. And then I would put in the equation with the negative on the first number. And what you're wanting to do is see how that changes. So I've already put this in my calculator. And I have them all in there, but I wouldn't suggest that with you. It'd be easier just to put in two at a time. So I have the original problem in y2 and the one with the negative in y4, and when I go zoom 6, the bolded one is the original. So as you can see, they both went through the same y-intercept, but it reflected. And it kind of looks like it moved over and reflected. Well, actually, that negative only made it reflect. It changed from up to down. The shifting part, well, that's more of a reflection type thought, because it really, once it reflected up, it had to still go through the y-intercept, and it just made it to work very well to flip over the y-axis, as well as flipping up and down. So this was a reflection. So if you look at your problem, you could say, what does putting a negative in front of A, B, and C do? Well, it looks like it reflects and shifts. It does look like that because it went from this to this. But at the same time, it's really just mostly about a reflection that negative 2 did. And the end behavior went from being rising to falling. So there's your clue right there. That's what the main difference is. Now if you put the negative on the middle one, let's see what that does. So I'm going back to y equals. I'm going to turn off the formula that I have turned on with the negative in front and turn on the one with the negative in the middle. Graph. Again, the bolded is the original formula, and the negative in the middle, well, the vertex basically looks like it just shifted over. It's still going through the same y-intercept, but it does look like it moved over. So putting the negative in the middle doesn't really change the y-intercept, but definitely shifts your graph. So we could say that it shifts to the right if I put a negative there. Then with the last one, we're looking at turning on the first equation and turning off this one. Well, I didn't turn on the first equation. Okay, and graph. So what if the negative's on the end? Well, as you can see, the graph basically has the same shape. It's going the same direction, but it made the y-intercept go from up at the top down to the bottom, from positive 5 to negative 5. And of course that moves the vertex as well, but it's really more about the y-intercept than it is about the vertex. So the vertex, the y-intercept. The y-intercept was at 0, 5, and now it's at 0, negative 5. So it shifted a lot in a different direction. Again, that end behavior didn't change in that problem. The end behavior didn't change in number 2. So the only time the end behavior changes is when your graph starts with a negative. Your formula starts with a negative. And that's important to know. Alright, let's look at the next format. This is called vertex format. Again, there could be a number out in front of the parentheses multiplied to the parentheses. There could be a number inside the parentheses being added or subtracted, depending on what you're putting in. And there could be some adding and subtracting on the end. So to make sure your problem's in vertex form, you need to make sure it only shows multiplication at the beginning. So when you're looking at fixing the formula, you want to make sure it shows only multiplication in front of that parentheses. If it looks like it shows adding or subtracting in front, your number's on the wrong end. For example, here on number 2, this 4 is on the wrong end. It should be add 4 on this end because the negative 1 times the parentheses needs to be at the beginning. Now, vertex form is called vertex form because it actually shows you the vertex. And we're going to get into that part here in just a minute. Well, we also wanted to see what this number A is doing on the front. So again, I'd like you to stop the video. I want you to graph each one of these. And I want you to graph these without having a first equation to look at. But I want you to graph these and basically decide this. Which way does it open? What is the end behavior doing? What part of the formula is causing that? So when you get finished doing these 4 questions, come back to the video and we'll go over what you found. So in our previous problems, the number in front of x squared was the one that told us whether it opened up, down, left, or right, opened up or down for the parabola. So in this case, this negative 2 in front multiplied is still representing A. So it's still going to be opening down, which makes it falling. This negative 1 also makes it open down and falling. And if you looked at both of those graphs, you is on the wrong end, so minus 6. So this 3 makes it open up because it's positive, which makes it rising. But this 4 over here is opening up because it's positive, so it's rising. Now, once you figure out if it's rising or falling, then let's talk about that vertex. So when you graphed this problem, your graph showed this. And what that basically is telling you is that this graph has a vertex at positive 3. So how did it get to positive 3 out of this problem? Well, first of all, if it's in a grouping symbol, it always sets it equal to 0 and solves. And if I solve that, I'll get positive 2. And then it just takes the number from the end because it's not in a grouping symbol and uses it the way it is. So because of that, your grouping symbols always make it do the opposite. So this one just went to the right 2, and that's how that x minus 2 did that. So in this one, it would be 1, 4, because again, x minus 1 equal to 0, you'd have to add 1 to get rid of the minus 1. So what would it be in this one? That's right, it'll be negative 4, negative 6, because you got to make it the opposite. And the last one would be negative 3, 5, because you got to make the x part the opposite. So the vertex form gives me the vertex, where the standard form gives me the y-intercept. So each one of these only gives me one thing about the graph. It gives me 1 point. Well, with the y-intercept, I could flip it over the axis of symmetry to get a second point, if I had the vertex and axis of symmetry. With this, I've got the vertex, but I don't have any points to flip over the y-axis, the axis of symmetry. But I know which way they all open so far, so that's good. Now, the next format's called factored form. And in factored form, there can be a number in front of the parentheses that stands for the GCF that you took out. And then you could have 2 parentheses that show how the problem factors. So all of these are in factored form because the multiplication of the coefficient is out in front to represent a GCF that you took out. So if you put each of these in the calculator, you should be able to tell if they open up or down. Does it reflect or not? Because reflecting means it opens down. And does this show the end behavior? So I want you to stop the video, graph each one, and decide, what does it open up or down? Does that show reflection or not? Because reflection means that it's opening down. And tell about that rising and falling. Now if you did that correctly, you'll notice that 1 and 3 both rose and 2 and 4 both fall. So it's this number in front still. It's that number that represents A. The very first number in your problem always tells you about that. That this is opening up. So it's rising. And so is this one. And this one over here, this -4 and this -1 shows it's opening down and falling. Now, this format does not give me the vertex, and it doesn't give me a y-intercept. It gives me zeros of the function, and those zeros of the function are very simple to find. They're x-intercepts. So when I bring this down, I make it the opposite because it's in a grouping symbol. So it'll be -2, 0. And when I bring this one down, I make it the opposite, and it's 3, 0. And that gives me my 2 zeros of the function. So over here, this one's going to be 4, 0 and -1, 0. And you just make them the opposite. And here's your answers for the last two questions. 5, 0, 7, 0 because they were both negative. I made them both positive. And then the last two became negative because the problem was positive. So x-intercepts are really helpful because they give you those places on the x-axis to try to make your graph longer. But this problem doesn't give me a y-intercept, and it doesn't give me vertex. Now in all of these three different formats, I get different things. The problem is, I gotta have a vertex every time. Doesn't matter if I have a y-intercept or zeros of the function, but I have to have a vertex every time because that's the center of the graph. So we need to look at how can we get that if we don't know it from the format that they give us. So the next thing we're going to do is look at 3 questions, and in these questions we're going to identify the parts that we can get from this formula to use to graph it. And as we do, we're going to graph it over here to the side. So the first thing we know is this problem right here tells me it's going to open up and it's going to rise. So that's important because if I'm drawing it the wrong direction, I'll catch that. It also tells me that this is the y-intercept, 0, -5. So I've got 1 point already. The problem I have with that is, you know, I can't flip that over the axis of symmetry. I don't know where the axis of symmetry is right now. So in that particular case, one of the things that you might want to do is know how to get the vertex, because the vertex and the axis of symmetry are in the same place. Now back in Math 1, you may have studied the quadratic formula. And in the quadratic formula, this part out here at the front represents the x of a vertex. So we can find our vertex by knowing -1 times b over 2a. So this is a, this is b, and this is c from my standard form equation. So if I do -1 times 3 for b, 2 times a would be 2 times 2. It comes out -3/4. Now, it would have been nice if that had come out a whole number because the math would have been tremendously easy with the whole number. With it being a fraction like that, you probably will end up wanting to just go and put this in the calculator and get the answer because it's not that simple of a question to get the answer for plugging negative 3/4 into this question. So you could either store negative 3/4 and just type the original problem with x's, or you can type this right here in math frac, and it comes out negative 49/8. So that means that I have an unknown y value here that we can only get from this type of process. So now we have our point. Negative 3/4 is about negative 0.75, which would be right there. And negative 49/8 almost a little over negative 6. So that's right there. Well, that's not much of a side, but it's at least 0.75 away from the point. So we'll go 0.75 over here, which will be about halfway between negative 1 and negative 2. And that's not really enough to make that parabola. That parabola is not good with 3 points. So like I said before, 3 is the minimum, but sometimes you might want more. Something else you could do is if your problem factors, you could get the zeros of the function. If your problem doesn't factor, you could go to table and just pick some more numbers on each side, like you could get negative 2 and positive 1 for that matter. But this one actually factors because negative 5 times 2 is negative 10, and 1 and 10 and 2 and 5 will only multiply to be that if it's negative on the smaller and bigger is positive. You could do the grouping process in which you fill in those two terms, split the problem and take out 2x, and that leaves me with x minus 1. Take out 5, that leaves me with x minus 1. So x minus 1 tells me that one of my intercepts is 1, 0, and 2x plus 5 tells me my other one is 5/2. And that would be negative 5/2 because the opposite of adding 5 is negative 5, and then you would divide by 2 to get rid of multiplying. So 1 is over here, and 2.5 negatively is right here, and if I extend those lines up through that, then I have a fairly decent parabola. So standard form, again, let's go through what it tells you. The first number tells you if it opens up or down, so it made a great graph opening up. The last number tells you the y-intercept, which you have to flip over the axis of symmetry. But to get that axis of symmetry, you have to do negative b over 2a, get the x value, that's where your axis of symmetry and the x of your vertex is, because this is our vertex, and x equals negative 3/4 is your axis of symmetry. And then we can flip that point over. If that makes my parabola too little, I can look for either the x-intercepts or zeros of the function by factoring, or I could just go to table and get some more points. Because this one's a fraction for the vertex, the points on the calculator would not be evenly spaced apart, but it would work. So now let's look at vertex form. Again, the first number in the problem tells you a lot about which way it's going to open. This one's going to open down, which means it's going to fall on each side. And my vertex in this problem is negative 1, negative 3, because I make the x part the opposite to bring it out of a grouping symbol, but I don't change the n number for the y. That means my axis of symmetry is x equals negative 1. So if I plot that, so what I've got so far, I've got an axis of symmetry through negative 1, and I have a point down here at negative 1, negative 3. Then I need more points. But with this particular format, I don't see another way to get it from just looking at it. So then I start thinking, well, what about a y-intercept? A y-intercept always has x is 0. So if you plug in 0 for x, you can calculate your own y-intercept. Now that comes out to be 1 squared is 1 times negative 2 is negative 2, minus 3 is negative 5. So my y-intercept is going to be at negative 5, which tells me this right here is going to reflect one place over from the axis will be one place over from the axis this way. Now that still looks like a fairly small parabola, but it is opening down like it said it would. Now, that graph's not going to cross the x-axis since it opens down, so I can't get x-intercepts. So the only way I could get more points is just go to the table and look up more. I could look up -3 and +1 and get some more points to get the rest of this shape to come through. I didn't hit my graph there. My board's off on that side. But you would need to plot those points to make that curve right, because if you don't use 2 more points, I don't know if that'd be a really good graph. It's awfully small without it. You don't know if that slant on each side is correct. So I used y-intercept, flipped it over to get a third point from having the vertex being given to me. In my third example, I have a negative at the front again. So again, this is going to open down. So that means it's going to fall. I have my zeros of the function. 4 is going to be negative when you make it the opposite. 2 is going to be positive when you make it the opposite. So these are my x-intercepts, or my zeros of the function. So let's start off plotting that. Over -4, stay on the axis. Over +2, stay on the axis. So I have a point on each side, but I don't know where the middle is. So to find the middle, you take your x-intercepts and you add them together and divide by 2 and find the midpoint. In this case, it comes out -2 divided by 2 is -1. That tells you half of your vertex. So now I also know the axis of symmetry is x equals -1. So that tells me to put a dotted line down through here. But it doesn't tell me where to put the vertex because I don't have the y value for that. So again, I've got 2 choices. I can either plug that number in and hand calculate the y value, or I could look up the -1 on the calculator to see what the answer for -1 is. So negative times 3, and this other parentheses is going to be -3. So that's like saying -3 times -3 is +9. Now I know where my point is, so I go up 9. Now I can't really go up 9 on my graph, so I'm just going to number by 2's, because there's nothing that says your graph has to be numbered by 1's. Although I did do 1's on the x-axis, I did not do 1's on the y, because they do not have to be the same scale. I plot it. Looks like my problem's pretty good with just using that. If I wanted the y-intercept, I could plug in 0 for x, and that would be -0 plus 4, 0 minus 2, which is negative times 4 times -2, which is 8. And it looks like my graph about hit there. I did a pretty good job of that, although it's off just a slight amount. That would make it more accurate if I had that point accurate, because then I could have the one on the other side accurate. So being able to get all the kinds of points with x-intercepts, y-intercepts, and vertex would make it more accurate. But I can make it with just 3 points if those 3 points are far enough apart to make it work. So that's what we covered today. We're planning to do a little bit more with this tomorrow, but we ran out of time today. Your homework was to finish the 1 through 10 I gave you yesterday. We talked some more about domain and range and increasing and decreasing today, so hopefully maybe that will make it a little bit easier.